So this project is about flow control. So from a historical perspective, if you look at the start of aviation over 100 years ago, the way aircrafts have been designed essentially have been based on a key premise, and that is to shape the surfaces of a vehicle such that the interaction with the flow would give you what you want, like generation of lift, reduced drag, and so on. In addition to this notion of intervention through shaping of a surface, we can provide an additional avenue for control. And that is essentially through the vibrations of the materials that forms the surface. We intervene in the design such that we get certain types of vibrations on the surface that interact very specifically with certain mechanisms in the flow, wave-like mechanisms, to give us further improvement in the performance, like reducing drag further, friction drag, delaying separation, and so on. And these vibrations are not the usual vibrations that we think of in terms of like vibrations of a whole structure like the wing. Rather, they're minute, localized vibrations that are at the level of the material. So the underlying concept is to control these vibrations totally passively through the introduction of substructures underneath the surface. So these substructures are essentially materials that have some form of architecture and vibrate in a manner to give us that function that we want. We are taking it to the realm of hypersonics. Hypersonics is an emerging field. Ultimately, the goal is to have vehicles that travel 5 times the speed of sound or higher. And because of the high speed, the temperature tends to be very high. So an additional requirement for these substructures or phononic subsurfaces is that they have to be temperature resistant. By reducing drag, you get less temperature, which gives you the opportunity to design for higher speeds and longer durations.